Okay, so today I'm going to be opening up the XY GT V1S Kyosho, and I'm going to be showing how I'm going to finalize the modifications I've made when I converted from nitro to brushless. We're going to build or design a proper motor mount. At the moment we've got one that I cobbled together from bits and pieces. So I'm going to start by opening everything up, and we'll get the motor out from where it is right now, and then we'll take some measurements and do a sketch, and then we'll draw up a proper mount. Okay, you can see here that everything's sort of crammed together. It wasn't designed to hold a battery, this car, and having the battery mounted high up like it is, it's not really great for handling and cornering, but it's what I could do, so that's what I did. Later on I might make a better battery mount for it. If so, I'll create a video for that too, but for now I'm just going to open it up and get into the motor. Okay, so here we are with the motor removed, and you can see here that I've utilised the nitro mounting system, and I've re-drilled holes, and I've cut up a steel bracket which I had lying around. There's actually a ignition coil mount in a previous life. So what I'm going to do now is take the main measurements we need to be able to turn this into a proper mounting system. So if we can remove these 3 screws underneath here and have just a one-piece unit, it's going to be much more reliable, and the adjusting will still work just fine, but we won't have an additional point where it can go wrong. So that's what we're going to do now. So for this part of the project, what we need is the item that we're going to be reverse engineering. In this case, I'm going to leave the motor mounted, because there's no need to dismantle it even further to do what we need to do. Some sort of measuring device. In this case, I'm going to be using a good vernier caliper, a pencil, and a sheet of paper. So the message here is that if you can sketch it, you can make it. We're going to put a step in between. We're going to sketch it, then we're going to draw it, and then we're going to make it. So let's get started by just doing a rough sketch of the shape that we want to achieve. So we're going to need a couple of mounting holes here, and we can see underneath, what have we got? We've got 4 main mounting holes, so we're going to need the 4 of those. Okay. Now what we're going to do is take some detailed measurements. Okay, so you can see on the sketch there we've got a roughly sketched shape of what we're going to be making. From here we need to add some dimensions to this. So we're going to take some detailed measurements and then we'll have the information we need to be able to replicate this in a much nicer form. So the first measurement I'm going to take is the measurement from the rear of the motor. The rear of the motor here. To the inside of the mount there. And so to do that, I'm just going to use the depth gauge end of the vernier, and we'll measure the depth. I'm trying to get that so you can see it. We'll measure the depth from the end of the bracket right to the inside face of where the motor is going to mount. And that looks like a straight up 59.5 millimeters. Now what we're going to do is measure the mount from the bottom surface here to just below the shaft there. So what I'd like to do is have this mount actually come up higher than the output shaft here, and then we'll slot it to suit. So let's get the vernier again, and I'm just going to sit this flush and measure from the flat to the shaft there. 25 millimeters should do that just fine. Okay, the next thing I want to look for is the height of the holes. Now these measurements don't have to be totally correct, but the closer we can get them the better. So in this case I have 17.4, which is close enough. And that's going to apply to both of these. Now we need to find the distance apart from the two holes. We're going to go centre to centre. And we've got 22.5. Alright, Now we need this distance here for both of those holes, and then the distance from here to here for these two holes. Now you can see here my sketch is not terrific. We're going to resolve that later, but it's going to take in all the details that we need. So that's there, 28 millimeters. And for this one, we've got 5.5. Now the distance between centers. Millimeters. So for now we pretty much have all of the information we need to know to be able to reproduce a bound. There are some variables here like the thickness of the material. You can see here I've got two different pieces of material. And the total thickness of those is shade over 5 millimeters of a piece of 3 millimeter aluminium and a piece of 2 millimeter steel. So given we're planning to make this from steel, what we're going to do is we're just going to probably utilize this 2 millimeter steel. And we'll eliminate the aluminium piece. Okay, there is another measurement there which I didn't capture, and that is the measurement of the shaft so that we can have a slot cut into the part we're making. So I'm just going to do a quick measurement of that now. And we can see that that output shaft is 5 millimeters in diameter. We'll be probably using a 6 millimeter radius inside there to give plenty of clearance around that shaft. So I'm just going to add that detail to the drawing here. Now, if you're looking at that drawing and thinking, what the heck, how is anybody ever going to make anything from that? Well, it's a pretty good question. So what we're going to do is we're going to take this sketch and we're going to turn that into a 3D model. As I've said before, if you can sketch it, you can make it. I also like to say if you can sketch it, you can draw it. And I wouldn't call this a drawing, I'd call this a sketch. We're going to go ahead now and create an actual drawing.